Here is a mirror problem from OpenStax College Physics in chapter 25. An object that is 1.5 centimeters high is held 3 centimeters from a person's cornea, and its reflected image is measured to be 0.167 centimeters high. What is the magnification? Where is the image? Find the radius of curvature of the convex mirror formed by the cornea. Now this is a really cool thing. Note that this technique is used by optometrists to measure the curvature of the cornea for contact lens fitting. Isn't that cool? All right, so let's start out by writing out the knowns and unknowns. Known. So we're told that an object is 1.5 centimeters high. That means that that's how tall the object is. That's the object height. So h sub o is 1.5 centimeters. That object is held 3 centimeters from a person's cornea. So that means that it is 3 centimeters in front of the human eye, of the eye lens really, but we're only looking at the cornea, which forms a convex mirror. So the distance then, the object distance, is 3 centimeters. Let's draw this out so that we can see what exactly is going on here. This would be the cornea, so the eye is behind it, and I place an object of height HO, a distance DO, away from the cornea. So this is the object with a certain height, and the object distance is the distance from the object to the mirror. Let's remember also that the distances in front of a mirror are positive, the distances behind the mirror are negative. And we will need to think about this the entire time for the problem. All right, let's continue with the knowns. So we know that its reflected image is measured to be 0.167 centimeters high. So we know that the image height is 0.167 centimeters. Now some problems just give you these values as positive quantities, like all of these things. And you have to actually draw your picture to see whether the those values are indeed positive if they go on this side, or if they're negative and go on the other side. So we established that HO and DO really are positive because they are on the shiny side of the mirror. But what is HI, positive or negative? So let's think about it. We know that in a convex mirror, images are virtual. So that means that they are formed behind the mirror. They're over here. The other thing that we know is that virtual images are upright. So that means that my image is on the other side of the mirror and it's upright. So indeed, the positive sign here is correct. Just to remember that we did look at these signs, I'm going to put a plus here, plus there, and keep in mind that we have to always check to see that those distances that the problem gives us are positive or negative. All right, now what we don't know, the unknowns, are the magnification, so that is just M. Where is the image? So we're looking for the image distance, D sub I. And also the radius of curvature of the mirror. Okay, so those are our knowns and unknowns. So let's get started. The first thing, it asks us to find magnification. Well, there are only two equations for magnification. One is image height divided by object height. The other one is the negative of image distance divided by object distance. Since our problem gives us both the object height and the image height, we can use those to solve for the magnification right away. So M is HI over HO, and HI is 0.167 centimeters divided by HO, which is 1.5 centimeters. Plugging in the numbers, we get 0.111 and there are no units because we divided centimeters by centimeters. So this is the magnification of the cornea. In part B, we want the image distance. So we can use now this equation. We now know the magnification. We know that the object distance, we can solve for the image distance. So I'm going to write m equals negative di over do, which then means that di, our unknown, will be negative m do. So negative m is 0.111, do is 3 centimeters, and when we multiply those together we get negative 0.333, and it's an image distance, so that's measured in centimeters. Stop and look, see if it makes sense. So I get a negative value for my image distance. Is that correct? A negative value means that the image is behind the mirror. Looking here, yes, image is behind the mirror, so the image distance is negative. Okay? Third part, we want a radius. The radius is actually twice the focal length. So we can solve for the focal length, and we use the mirror equation. 1 over f is 1 over do plus 1 over di. Do is 3 centimeters. Di is, what is di? Negative 0.333. And when we plug in the numbers, we get negative 2.66 centimeters to the negative 1, because we have just solved for 1 over f. So the units for 1 over f are 1 over centimeters, because we started out with centimeters. So we don't want 1 over f, we want f, and that is 1 over negative 2.66. So that's negative 0.376 centimeters. That's also not what we're looking for. We want the radius of curvature. It's 2 times f. And if you plug in the numbers, you get negative 0.752 centimeters. Let's check that the answer makes sense. We get a radius and a focal length that are negative. Negative focal length means that they are on the wrong side of the mirror, not on the shiny side of the mirror, but on the back of the mirror. So if I were to extend the surface from which we cut out the lens, well, in our case is the eye, then the center of curvature would be somewhere here, the focal length would be somewhere there, not drawn to scale, of course, and then we notice that those things are on the wrong side of the mirror and they are, negative. Okay?